Hello everyone, in this video we're going to review Unit 4 for AB, Calculus, AB and BC. Alright, question number 1. If a rock fans enter a line to buy tickets to see the renowned band Sir Isaac and the Newtons at a rate modeled by the function e of t equals 512.7 e to the negative 0.173 t, where et is measured in people per minute and t is measured in minutes for the interval 0 to 30. Find e prime of 22. So basically, we need to calculate the derivative of this one and then we substitute 22 for t, right? This one is the calculator active problem. So we're going to bring up the calculator, right? Now we need to store the function, right? So in order to store the function, we need to enter e of t, right? So I have e right here of t. And then you press Ctrl and put it next to number 9. And then you enter 512.7 times e to the negative 0.173, right? And then press enter, done. Now we need to calculate e prime of 22, right? So we just press the button right here, derivative right here. So we take derivative of this one with respect to t, right? And this one should be e of t. Then press Ctrl equal sign, put a line right here, and then type t equals 22. And then press enter. The answer is negative 1.97235, right? Now, be careful with the unit. The unit should be people per minute and per minute, right? Because this one is the rate of this one, right? So you need to say people per minute, or you just say people per minute square, right? Now, we need to interpret its meaning in the context of the problem. So we need to say the rate at which people entering the line to buy tickets is decreasing by 1.972 people per minute, right? Now let's move on to question 2. The graph below shows the velocity v of t of a particle moving along the x-axis can be defined by a continuous linear piecewise defined function over the interval 0 to 9. Note that v prime of t equals 0 on the interval 3, 4. So 3 right here and 4 right here. You see the horizontal line, which means the slope equals 0. Right? Remember, we have the Christmas tree trick. If the line is going this way, the slope is positive. If the line is going this way, the slope is negative. If the line is horizontal, the slope is 0. If the line is vertical, the slope is undefined. Alright, so we go back over here. Question A. Over which time intervals does the particle move to the left? So keep in mind, when the particle moves to the left, v of t must be less than 0. Alright, move to the right, v of t must be greater than 0. Right? Now, this is the function v of t. So v of t less than 0, which means it's below the axis, right? So it's going to be this guy right here, below the axis, and this guy right here, right? So the interval should be 0 to 2, right? union 6 to 9, right? Because v of t less than 0 on those intervals. Now question B. Over which time intervals is the particle speeding up? Alright, so when the particle speeding up, v, t, and at should have the same sign, right? So which means vt greater than 0, at greater than 0, or vt less than 0, at less than 0. Or you can combine these two guys as one inequality. That's equal vt times at always greater than 0, right? First, we need to check where vt greater than 0. So vt greater than 0, which means it's above the axis, right? So it's going to be from here to here, greater than 0, right? And then at must be greater than 0, yes, because at is the derivative of vt, right? Which is the slope of vt, right? The slope right here is positive. Look at the Christmas tree trick right here, right? So it should be from 2 to 3, right? So I'm going to write over here 2 to 3 union. Now this guy is above the axis, but at is less than 0, right? Because the slope right here is less than 0, right? Look at the Christmas tree trick right here, right? Now next one, vt less than 0 and at less than 0, right? So vt right here is less than 0, but at is greater than 0, right? Because the slope right here is positive, right? This guy less than 0, right? And at less than 0, right? So this one was from 6 to 8. Now this is vt less than 0, but at greater than 0, right? So union 6 to 8 only. Because v, t, and a, t have the same sign. Now let's move on to question C. Over which time intervals is the particle's speed decreasing? Now you need to be careful. Speed decreasing is different from velocity decreasing. Okay? Speed is the absolute value of velocity. So be careful. Now speed decreasing is the same thing as slowing down, right? It means velocity and acceleration have the opposite sign. In other words, vt times at less than 0, right? Now, vt and at have opposite sign when t from 0 to 2 right here, right? Because on this interval, vt less than 0, right? Because it's below the axis, and at is greater than 0, right? Because the slope right here is positive. And then this one right here, vt is greater than 0, but at less than 0, right? Because the slope is negative. And this interval right here, from 8 to 9, vt is less than 0, at is positive, right? So you have three intervals. It's going to be 0 to 2, union 4 to 6, union 8 to 9, right? Now let's move on to question 3. If square root of x plus y equals 6, dy over dt equals 2, find dx over dt when x equals 4. Now let's move on to question 3. If square root of x plus y equals 6, dy over dt equals 2, dx over dt equals how much when x equals 4. Okay, so first we need to take derivative both sides with respect to t, right? So derivative of square root of x is 1 over 2 square root of x Alright, I'm going to show you the faster way to calculate the derivative of square root of x. It's going to be square root of x prime equals 1 over 2 square root of x. Square root of u prime equals u prime over 2 square root of u, where u is a composite function. So keep that in mind. Alright, so this guy turns out to be dx over dt, right? Now, plus derivative of y is going to be 1, right? So dy over dt left, right? Equals derivative of z equals 0, right? Now you just plug in values. S equal 4, substitute over here. So 2 square root of 4 is going to be 4, right? So it could be 1 over 4 dx over dt, right? Plus dy over dt equals 2 right here. Equals 0, right? Now subtract 2 both sides and then multiply both sides by 4, right? So we have dx over dt equals -8. This one is the final answer, right? Now let's move on to example number 4. A kite is flying at a height of 40 feet, right? So this one is the height, 40 feet right here. A child is flying it so that it's moving horizontally at a rate of 3 feet per second. Horizontally is right here, right? And this one should be dx over dt equals 3, right? Dx over dt. Now, if the string is taut, at what rate is the string being let out when the length of the string released is 50 feet? So this one is z, right? Z right here is the string, right? The question asks you at what rate is the string being let out, which means dz over dt equals how much, right? Now look at this one. This is a right triangle. We're going to use the Pythagorean theorem, right? So we have z squared equals s squared plus h squared, right? Now we're going to take the derivative both sides with respect to t, right? So the question asks you what is the dc over dt, right? Now look, z equal 50 fits right here. You're not gonna substitute 50 directly over here, because if you substitute 50 over here, when you take the derivative, it's gonna be 0, right? But we need dc over dt, right? So we just leave this one as variable. So we have 2z dc over dt, right? Equals. Same thing. We given dx over dt equal 3. We need to use this one, right? So, check the derivative of this one with respect to t. It's going to be 2s dx over dt, right? Now, the height right here is given right here, 40, right? We substitute 40 for h right here. And then when we take the derivative, it's going to be 0, right? Now, we given z equals 50 right here, right? So we have 2 times 50 times dz over dt equals 2 times s, but s is not given, right? Now, we're going to calculate s on the side, right? So we have z squared equals s squared plus h squared, right? Z is equal 50, right? So we have 50 squared equals s squared plus 40 squared, right? So s squared equals 50 squared subtract 40 squared, right? And it's going to be 2500 subtract 1600. It's going to be 900. Take square root both sides, so s equals 30, right? Substitute 30 over here, right? So we have 2 times 30 times dx over dt equals 3, right? So times 3 right here. Then dz over dt equals 2 times 3 equals 6 times 30. It's going to be 180, right? Divide by 100, right? So it could be 18 divided by 10, and it's going to be 9/5, right? Now don't forget to include the unit. It's going to be feet per second, right? Now let's move on to question 5. A spherical snowball is being made so that its volume is increasing at the rate of 8 cubic feet per minute, right? So increasing, which means positive, right? The rate, so which means dv over dt equals 8, right? Now find the rate of change at which the radius is increasing when the snowball is 4 feet in diameter, right? So we have diameter equals 4, and then radius equals 2, right? Now the question wants you to find the rate of change at which the radius is increasing, which means you need to find dr over dt equals how much, right? So we're going to use this formula right here. Take derivative both sides with respect to t, right? So we have dv over dt equals, bring 3 to the front, it's going to be 4 pi r squared, right? Don't forget dr over dt, right? So this is what we need to find, right? dv over dt equals 8 right here, right? So substitute 8 equals 4 pi. The radius is 2, so square is going to be 4 dr over dt, right? And then dr over dt equals 8 divided by 16 pi, right? So it could be 1/2 pi, right? Don't forget the unit feet per minute, right? Let's move on to example number 6. Sand is being dropped onto a conical pile at a rate of 10 cubic meters per minute. So this guy gained sand. So it should be dv over dt equals 10, right? If the height of the pile is always twice the base of the radius, right? So this is the height right here and the base right here, right? So this is the radius. This guy's the height should be 2 times r, right? So we connect this one, we make the right triangle right here, right? At what rate is the height increasing when the pile is 8 meter high, right? So the height is 8. Then the radius must be 4, right? And they ask you to find dh over dt. Now, we're going to take the derivative of both sides with respect to t. But keep in mind, dr over dt is not given, right? So if we leave it like this, and when we take the derivative both sides with respect to t, we get dr over dt, right? Look, we have dv over dt equals 1/3 times 2rh dr over dt plus dh over dt times r squared, right? So we have dr over dt right here, but it's not given, so we stop right here, right? So don't do this way. We need to use the information right here, right? The height is double radius, right? So we need to convert every single thing in terms of height, right? So this mean radius equal the height divided by 2, right? So we have v equals 1/3 pi times height divided by 2, and then square, right? Times h. Now we're going to simplify, so it will be v equals 1/12, right? Pi times h cubed, right? Now we're going to take the derivative both sides with respect to t. So we have dv over dt equals 1/12 times pi. Alright, bring 3 to the front. So it turns out to be 1 over 4, right? Times pi times h squared times dh over dt, right? And then we just substitute values. dv over dt equals 10 equals pi over 4 times h right here is 8. H squared equals 64, right? Times dh over dt, right? Now 64 divided by 4 it could be 16, right? So dh over dt equals 10 divided by 16 pi, right? Or 5 over 8 pi, right? Don't forget, unit, it should be meter per minute. Now let's move on to question 7. The volume of a cube is increasing by 10 cubic centimeter per minute. So this one actually dv over dt, right? Find the rate of the surface area, which means dA over dt, right? Is increasing when the size of the cube is 5 centimeter, right? So I call the size of the cube as B, right? So B right here is 5. This one still B, this one still B, right? Now remember, we need to calculate dA over dt. We know that the surface area is the area of one side multiplied by 6, right? So the area of one side should be B squared, right? Then you multiply by 6, right? Now to calculate dA over dt, check derivative both sides with respect to t, right? So we have dA over dt equals 12b dB over dt, right? But dB over dt is not given, right? We have it right here. So we need to use the volume formula to calculate dB over dt, right? The volume of the cube equals b cube, right? Take derivative both sides with respect to t. So we have dv over dt equals 3b squared dB over dt. Now we substitute value dv over dt equals 10 right here. So we have 10 equals 3 times b equals 5, right? So it will be 5 squared times dB over dt, right? Then dP over dt equals 10 divided by 75, right? If you simplify, it's going to be 2 over 15. Then we substitute 2 over 15 for dB over dt right here, right? So we have dA over dt equals 12 times b equals 5, right? And then times 2 over 15, right? Now if you simplify 5 and 15 to here, it's going to be 3. 12 divided by 3 is going to be 4. 4 times 2 is going to be 8, right? So dA over dt equals 8 square centimeter per minute, right? Now let's move on to question 8. Oil is leaking from a pipeline on the surface of a lake and forms an oil slick whose volume increases at a constant rate 2000 cubic centimeters per minute, right? So we have dV over dt equals 2000, right? The oil slick takes the form of right circular cylinder with both its radius and a height changing with time, right? So we just draw the cylinder at the instant when the radius of the oil slick is 100 centimeters and the height is 0.5 centimeters, right? So this is the radius right here. This got 100, right? And the height right here is 0.5. The radius is increasing at the rate 2.5 centimeters per minute. So we have dr over dt equals 2.5, right? At this instant, what is the rate of change of the height of the oil slick with respect to time in centimeters per minute? So we need to calculate dH over dt, right? Now we need to use the volume formula right here. This is the volume formula of the cylinder, right? So we need to take the derivative both sides with respect to t. So we have dv over dt equals pi. Now we need to use the product rule, right? So we have 2r times h dr over dt plus r squared dh over dt, right? Now we just substitute the values. Dv over dt is given by right here, right? So it could be 2000 equals pi times 2r. R equals 100, right? So we have 2 times 100 times 0.5. dr over dt is going to be 2.5, right? Plus 100 square times dh over dt. We don't know it. We need to find, right? So we put dh over dt here. Now we need to simplify. We have 2000 here equals pi. Now 2 times 0.5 is going to be 1, right? So 1 times 100 is going to be 100 times this one is going to be 250, right? So we have 250 times pi, right? Plus 100 square is going to be 10,000 pi dh over dt, right? So dh over dt equals 2000 subtract 250 pi divided by 10,000 pi, right? Now we're going to simplify this one. So we just divide the top and bottom by 10. So we have 200 subtract 25 pi divided by 1000 pi, right? And then we just divide the top and bottom by 25, right? So it should be 8 minus pi divided by 40 pi centimeter per minute, right? Now let's move on to question B. A recovery device arrives on the scene and begins removing oil. The rate at which oil is removed is given by this function, cubic centimeters per minute, where t is the time in minutes since the device began working. Oil continues to leak at a rate of 2000 cubic centimeters per minute. Find the time t when the oil slick is not changing the volume. Alright, so the rate of change of the volume of the oil is leak rate subtract removal rate. Find the time t when the oil slick is not changing the volume. It means this guy subtract this guy equals 0. Right? Now we have leak rate is to be right here. 2000 subtract 400 square root of t equals 0, right? And then it's going to be 400 square root of t equals 2000, right? And then square root of t equals, divide both sides by 400, it's going to be 5, right? Square both sides, so t equals 25 minutes, right? Now let's move on to question 9. Meanwhile, Mr. Julio decides to get some punch from the freshman table. The punch is being served from the conical punch bowl with a spigot at the bottom. The volume is given by 1/3 pi r squared h. Mr. Julio notes that the punch bowl has a diameter of 18 inches and the height of 12 inches, right? So the diameter is the distance from here to here, right? As he serves himself punch from the spigot, he knows that the height of the punch in the bowl is decreasing at a rate of 1/2 inches per second, right? So d little h over dt equals negative 1/2, right? Decreasing, which means negative. And the height of the punch at this moment is 6 inches. Right, so this one is 6. How fast is the volume of the punch in the bowl decreasing at the moment? So we need to calculate dV of dt equals how much? Now remember, dr over dt is not given. So when you take derivative both sides with respect to t, you're gonna get stuck because you have dr over dt right here, right? So you need to use the similar triangle you learn in geometry to calculate r in terms of h, right? So remember, we have this triangle right here and the bigger triangle right here, similar, right? So we have the little r over 9 is the same thing as the little h right here over 12, right? And then r equals 9 over 12 times h is going to be 3h divided by 4, right? The volume formula can be written as V equals 1/3 pi r squared times h, but r equals 3h over 4, right? So we have V equals 1/3 pi times 3h over 4 square times h, right? And then V equals 3 squared equals 9 divided by 3, it could be 3. So we have 3 pi over 16h cubed. Now you can take derivative both sides with respect to t, right? So we have dv over dt equals 3 pi over 16. Bring 3 to the front, so this guy becomes 9, right? H squared dh over dt. dv over dt is what we need to find, right? Equals 9 pi over 16. H equals 6 right here, right? So it could be 36 times dh over dt, it could be negative 1/2. Right? So if you simplify this one, it turns out to be 36 divided by 2, it could be 18, right? 18 divided by 2, it could be 9. And this guy divided by 2, it could be 8, right? So we have 81 pi over 8. Don't forget negative sign, right? And the unit should be cubic inches per second, right? So you need to conclude that the volume is decreasing at 81 pi over 8 cubic inches per second, right? Now question B. How fast the circumference of the surface of the punch decreasing at the moment? It's actually the circumference of this circle right here, right? So we have circumference is given by c equals 2 pi r, right? But r equals 3 over 4 times h, we calculate above, right? So it's going to be 3.5 pi times h, right? Now we need to take derivative both sides with respect to t. So we have dc over dt equals 3 over 2 pi dh over dt, right? And it's going to be 3 over 2 pi. dh over dt is given by this one right here, right? Negative 1/2 is going to be right here. So times negative 1/2. So it's going to be negative 3 over 4 pi, right? Don't forget to include the unit. It's going to be inches per second. So we need to conclude that the circumference is decreasing at 3/4 inches per second. Now, question C. Mr. Julio is serving the punch into the cylindrical paper cup with the radius of 4 inches and the height of 5 inches. How fast is the height of the punch in his cup increasing at this moment? Right? So, this one right here. The radius is 4, right? The height is 5, right? You need to find dH over dt of this cylinder right here, right? Now remember, the volume of the cylinder is given by V equals pi r squared times h, right? And then remember, you have dV over dt is negative 81 pi over 8 from this guy right here, right? So if this guy leaking, does that mean this guy right here gaining, right? So basically, negative 81 pi over 8 becomes positive for this guy right here, right? So I'm going to use the formula V equals pi r squared times h, right? And then it's going to be pi times 4 squared times h, right? Now remember, you need to calculate dH over dt. So you're not going to substitute 5 for h over here, because if you do like that, you take the derivative both sides, it's going to be 0, right? So be careful, you need to keep that one. So you need to calculate dH over dt right here. Alright, so we just substitute 4 for r, right? So now, you're going to take the derivative both sides with respect to t. So dV over dt equals 16 pi dH over dt. Now remember, dV over dt is 81 over 8 pi, right? Equals 16 pi times dH over dt. Now dH over dt equals 81 pi divided by 8 times 16 pi right here, right? So pi and pi cancel out, right? And I have 81 divided by 128, right? And don't forget the unit is going to be inches per second, right? Now let's move on to question 10. Use the tangent line approximation for f of s equals square root of s at s equals 64 to approximate square root of 65 minus square root of 63. Alright, so first we need to take derivative of this one, right? Derivative of f of s equals 1 over 2 square root of s, right? Now you need to calculate f of 64. Substitute 64 over here. It's going to be square root of 64, and it's going to be 8. Also, you need to calculate f prime of 64 to find the slope, right? So it will be 1 over 2 square root of 64, right? So it will be 1 over 16, right? Now remember, the equation of the tangent line is given by the formula y minus y1 equals m times s minus s1, right? M is right here, the slope, right? So we have equation is going to be y minus 8, right? This one right here, y1 equals, the slope is 1 over 16 times s minus s1. S1 is given by right here, right? 64. Remember, the order of pair should be 64, 8. So keep that in mind. So I need to rewrite this one in the slope-intercept form, right? And I have y equals 8 plus 1 over 16 times s minus 64, right? So I name y as L of s, right? Equals. So I have f of square root of 65 minus f of square root of 63, right? Is So actually x equals 65 and 63, right? Substitute 65 and 63 for x into this expression right here. So you have 8 plus 1 over 16 times 65 minus 64, right? Minus the second one, 8 plus 1 over 16, 63 minus 64, right? So we have 8 plus 1 over 16, right? Negative 8 plus 1 over 16, right? So it's going to be 2 over 16 and it's going to be 1 over 8, right? Now question 11. Let g be a function given by g of x equals this. F of negative 1 equals 3. F prime of negative 1 equals negative 2. Use the tangent line to g at x equals negative 1 to approximate g of negative 0.9, right? So we need to calculate g prime of x, right, to find the slope first, right? So we're going to use the product rule, right? So it could be f of x plus x times f prime of x, right? And then you need to calculate g prime of negative 1, right? Look at x equals negative 1. So it could be f of negative 1 minus 1 times f prime of negative 1, right? So it's going to be f of negative 1 is 3 right here. Minus f prime of negative 1 is negative 2, right? So minus negative 2 is going to be 5, right? Now you need to find the order pair, right? So we have g of negative 1 is substitute over here. So we have negative 1 times f of negative 1, right? So it could be negative 1 times 3 is going to be negative 3. So the order pair should be negative 1, comma, negative 3. Now we're going to use the equation y minus y1 equals m times s minus s1, right? M is 5 right here, right? So we substitute, so we have y equals 5 times s minus s1, which means negative 1 right here, right? And then you add y1 both sides, right? Which means negative 3. So we simplify, it's going to be 5s, right? Plus 2. Now you can replace y with L of s, right? G of negative 0.9 is the same thing as L of negative 0.9, right? It's going to be 5 times negative 0.9 plus 2, right? So it's going to be negative 4.5 plus 2, and it's going to be negative 2.5, right? Let's move on to question 12. Given a function f of x, the linear approximation for this one is given by what, right? So we have the linear approximation, tangent line should be y minus y1 equals m times s minus s1, right? Or y equals m times s minus s1 plus y1, right? Now, suppose s equals a right here, right? So in order to find y, doesn't mean we need to calculate f of a, right? And in order to find the slope of the tangent line at s equals 8, doesn't mean we need to calculate f prime of a. And this guy actually the slope, right? So substitute this guy right here s1, this guy y1, back o right here. So we have y actually L of s, right, equals m, which means f prime of a times s minus a plus f of a, right? So f of a plus 0.1 is right here, right? Is the same thing as L of a plus 0.1, right? So substitute a plus 0.1 for s, right? So it's going to be f prime of a times a plus 0.1 minus a, right? Plus f of a, right? So it's going to be f prime of a times 0.1, right? Plus f of a. Now 0.1, which means 1 over 10, right? So we have f prime of a divided by 10 plus f of a, right? So the answer must be B. Now let's move on to question 13. Find the error using the linear approximation of LS equal this one at S equal 1 to approximate this one, right? So first we need to find the equation of the tangent lines, right? So we have f prime of s equals 2 times 1 minus 2 s times negative 2, right? So we have negative 4 times 1 minus 2s, right? So we have f prime of 1, right? Because the equation of the tangent line at this point. So it could be negative 4 times negative 1, so the answer is 4, right? Now we need to find the order pair, right? So we need to calculate f of 1. It's going to be substitute is so it will be 1 minus 2 square equals 1, right? So the order pair x1, y1 equals 1 comma 1, and the slope is right here, right? So the equation of the tangent line is y minus y1. y1 is 1 equals m, which is 4 times s minus s1, which is 1, right? So if I simplify this one, it's going to be 4s minus 4, and then you add 1, it's going to be minus 3, and replace y with L of s, right? Now we need to approximate this one, right? So the estimate is L of 0.9. It's going to be 4 times 0.9 minus 3, right? So it's going to be 3.6 minus 3. It's going to be 0.6. Now we need to find the actual value, right? The actual value is, we substitute 0.9 into this equation here, right? So we have f of 0.9 equals 1 minus 2 times 0.9 altogether square, right? So it could be 1 minus 1.8 altogether square, right? So it could be negative 0.8 square, so it could be 0.64, right? Now the error is absolute value of actual subtract estimate, right? Remember, you have a trick to memorize. It should be E, A, E, right? A between 2E, right? So it could be absolute value of 0.64 subtract 0.6, right? So it could be 0.04. So the answer must be A. Now let's move on to question 14. We need to find the limit of this one, right? So we need to find the limit of the numerator first when s approaches 1. It's going to be e times 1 minus e to the first, right? So it could be 0. Now the bottom limit when s approaches 1 equals 1 minus 1 equals 0. So you have the indeterminate form 0 over 0. We need to use the LaSpero rule, right? So we have limit when s approaches 1, take derivative of this one should be e. Derivative of this one should be e to the s, right? Derivative of this one should be 2s, and derivative of 1 should be 0, right? Now substitute 1 for s, so the answer is e minus e over 2 times 1, right? So the answer is 0. The answer must be D. Now question 15. The function f is continuous and twice differentiable for all s value. And given this one, what is the following limit? Alright, so again, we need to split the top. Limit when s approaches 0. Right, substitute over here, so we have f of 0 minus 1. Right? Now f of 0 equals 1, so 1 minus 1 equals 0. Limit when s approaches 0, sine of 0, right, minus 0, right? So the answer is 0, right? So this one is the indeterminate form, right? So we need to use the L'Hospital rule, right? So we have limit when s approaches 0, derivative the top should be f prime of s minus 1 over the bottom should be, we need to use the chain rule, right? Sine of u prime equals u prime times cosine of u, right? Now u is 2s, right? So we have 2 times cosine of 2s minus derivative of this one is 2s. Derivative of this one should be negative 2, right? We check to see if this one still in the determinate form, right? Substitute 0 for s, so the top should be what? F prime of 0 minus 1 is f prime of 0 equal 1, so it could be 0 again. The bottom, cosine of 0 equal 1, so we have 2 times 1 minus 0 minus 2 equals 0 again, right? So the L'Hospital rule applies again. So we have limit when s approaches 0. Derivative of this one should be the second derivative, right? Derivative of negative 1 is 0 over derivative of this one, use the chain rule, right? It's going to be u prime sine u, right? Don't forget the negative side right here. So it could be negative 2 times 2, it will be negative 4 sine 2s, right? Minus 2 for this one, right? This one equals 0, right? Now substitute 0 for s, we have f prime of 0. Now substitute 0 for s, so we have f double prime of 0 is actually right here, equal to the bottom. We have negative 4 times 0 equals 0 because sine of 0 equals 0. So negative 2 right here. So the answer is negative 1. The answer must be A. Now let's move on to the last one. Find the following limit. Limit of e to the 2t minus 1 over sine t when t approaches 0. Alright, so find the limit on the top, right? E to the 2t minus 1 when t approaches 0. It's going to be e to the 0 minus 1 equals 0. Limit of sine t when t approaches 0. Sine of 0 equals 0. So this one is the indeterminate form, right? So we need to use the L'Hospital rule, right? So we need to say L'Hospital rule applies. So it's going to be limit when t approaches 0 of derivative of e to the u prime is going to be u prime times e to the u. Or you can apply the formula right here. E to the a s plus b prime is going to be a times e to the a s plus b, right? So this guy turns out to be 2 e to the 2t over cosine t, right? Substitute 0 for t, the top should be 2, the bottom should be 1. The answer is 2, right? And it's good time to stop.